So here we have lesson 5 of Unit 1, talking about scale diagrams. Great white sharks can grow to a length of approximately 6.5 meters. The diagram is a scale drawing of a great white shark. To determine the actual length of the shark, we need to know the scale used in the diagram. Scale can be given in the following ways. 1. As a statement. 1 centimeter represents 0.5 of a meter in real life. This statement that's saying here is that this statement tells us that 1 centimeter on the diagram represents 0.5 meters of actual length of the shark. As a rate, 1 centimeter to 0.5 of a meter, or 1 centimeter divided by 0.5 of a centimeter. So that's how we would write it if we wanted to write it as a rate. As a ratio, we are going to be writing, select the pen here, we're going to be writing it as a 1 to 50. Now why is it 1 to 50? Well, because this ratio here is in different units, and we've got to change the units to the same unit. So if you think about it, this is really 1 centimeter, and 0.5 of a meter, every meter is worth 100 centimeters, so 0.5 of a meter is 50 centimeters, so it's 1 to 50. So here's a ratio, 1 to 50. So make sure you look at the units in the statement. 1 centimeter to 0.5 meters has to be converted. So this ratio indicates 1 unit on the diagram represents 50 units of actual length of the shark. As a line graph, well, as a line graph, what does it look like? As a line graph, or line scale rather, we have the scale right here, and as you can see, scale measures indicates a measure of 1 centimeter on the scale. Diagram represents 0.5 meters of actual length on the shark. So this line graph scale is actually what you would typically see on a map. It gives you the actual scale of the drawing on the map. So this would be included typically with a map or with the shark, that you could just take a measure, say from this point to this point, and know that the distance was actually 1.5 meters in real life. Okay, so looking at class example number 1, the lengths of sharks are generally measured from the tip of the nose to the middle of the tail. Measure the length of the shark in the scale diagram and use proportional reasoning to determine the actual length of the shark. Well, the shark measures in the diagram 9.6 centimeters. We know that 1 centimeter represents 0.5 meters. 1 centimeter in the diagram is 0.5 meters in real life. So proportional representation, we need an equivalent fraction. We have 9.6 centimeters in the diagram. X, what is the actual length of the shark in real life in meters? So centimeters, centimeters, meters, meters. So set it up with the same units as here. Okay, we can do the crisscross where we do 0.5 times 9.6 equals, 0.5 times 9.6 divided by a spare number equals x. Now what we have written here is that x times 1, crisscross rule, x times 1 equals 0.5 times 9.6. And then we divide both sides by 1. If you follow my way of doing the crisscross, multiply the pair, divide by the spare, in this case as well. So x, when you do that, equals 4.8. So that would be the actual length in meters, 4.8. Okay. Down, and back, and select. Okay, so looking at the next page, page 34, make sure you're writing these as we go along. Make sure you're writing the answers to these class examples. So we have a scale diagram here, map of Alberta, and we have a scale at the bottom, legend as well. And example 2 says, use the line graph scale. So the line graph scale is this thing here, and we're going to use that to determine the approximate straight line distance between Calgary and Edmonton. Alright, so approximate. So let's just scroll up and look at where Alberta is and where Edmonton, where Edmonton is. So let's find Edmonton, it's right here. And Calgary, almost directly below, directly south. And looking at that distance, to me, probably want to look at a ruler on your paper. But I'm looking at this on the computer, of course. It looks probably a little bit further from about here to about, I'd say, somewhere in the region of here. So how far is that? So every division here is 75, so I think it's slightly more than one more division. It looks more like it's just over 300 kilometers in other words. So let's scroll down and have a look. Well, they're saying that 1 centimeter represents 75 kilometers, as it does. Okay, and measure on the map. We're measuring 3.6 centimeters. Okay, so if we do it this way and we use the line graph, we can say that 1 centimeter is 75 kilometers. These are centimeters right here on the scale. And we measure 3.6 centimeters on the map. What is the actual distance? We can use the crisscross again. 75 times 3.6 equals x times 1. So 1x is 75 times 3.6, or 270. So I had thought it was about 300, and I was a little bit off. Okay, looking at the next example, and another map, this time BC. We also have a scale with this one. And example 3 is saying, calculate the approximate straight line distance between New Hazelton and Prince George. Okay, well, the scale on the map, 1 centimeter represents, in this case, 100 kilometers. So here's a ratio, 1 centimeter per 100 kilometers. If we measure the distance between New Hazelton and Prince George in the map, you'll find that it is 3.4 centimeters. So we can set up another ratio. 3.4 centimeters on the map is equal to x kilometers in real life. So centimeters to kilometers here equals centimeters to kilometers here. Crisscross, again, 3.4 times 100 equals 1 times x. So here's the calculation, and we get 340 kilometers for the value of x. Is the answer in A a realistic estimate of the actual driving distance? So driving distance between New Hazelton and Prince George? Well, not if the road is windy. Describe a method for determining a more accurate estimate of the driving distance between Hazelton and Prince George. Since the road is not a straight line distance is not an accurate approximation for the driving distance. For a better approximation, calculate a straight line distances from New Hazelton to Houston and from Houston to Prince George and then add them. If you want, obviously, the distance by road. That's example 4. Tyler's scale diagram of a tower is shown. The actual tower is 240 meters tall. And notice the height in the diagram is only 8 centimeters. So 8 centimeters represents 240 meters. And we can look at therefore what 1 centimeter equals. We can say divide this by 8 to get 1. So divide this by 8 to get 30. Every centimeter is worth 30 meters. So if we want the scale in statement form, 1 centimeter represents 30 meters, and as a rate, that's 1 centimeter to 30 meters. As a ratio, 1 to 30, but remember the units are different. So be careful if you're writing as a ratio. Really, we only want numbers, not any units. As a rate, we can actually put units in, or we could say in a statement form we can include units. But when it comes to ratios, it's 1 actual unit represents 300 units in real life. So let's change these to the same units. I guess we can change 30 meters into centimeters by multiplying by 100. So we get 3,000. So 1 centimeter to 3,000 centimeters in real life, or 1 to 3,000 is the actual scale as a ratio. Looking at class example 5, Kylie from Abstract Renovations designs a plan for a candy store to be renovated. So the scale drawing on the plan of the candy store is 1 centimeter to 50 centimeters. Notice the units are the same here, both centimeters. What are the actual dimensions of the storage room if the scale diagram dimensions are 8 centimeters by 12 centimeters? 8 by 12. Well, you can see the ratio is 1 to 50. So what will 8 become? 8 in real life, 8 in the diagram represents what in real life, just as 1 centimeter on the diagram represents 50 in real life. So 8 is to x as 1 is to 50. This is a scale. 1 to 50 equals 8 to the unknown value x. We can crisscross again and say that 8 times 50 equals 1 times x. 8 50s are 400. What about the 12? You can do that in various ways, of course. It's going to be 1.5 times this, so it's got to be 1.5 times this, so it's 600. Or set up the ratio again of 1 to 50 is equivalent to 12 to y. And crisscross, we'll get 12 times 50 is 600. So actual dimensions are 400 by 600 centimeters, or 4 by 6 meters. Part B. What are the dimensions on the plan if the dimensions of the chocolate section of the store are to be expanded to be 3.5 meters by 4.75 meters? What are the dimensions on the plan? So here we're taking the actual dimensions and changing them to dimensions on the plan. So let's look at our scale. We know from above it's 1 to 50. 1 in the drawing is 50 in real life. And we have 3.5 meters in real life. So we can use 3.5 meters or turn it into 350 centimeters, which is probably best because on the drawing we're dealing with centimeters. Okay, so we know that it's going to be 1/50th of the actual size. So 1/50th times 350. So we can use that as a fraction if we want, multiplying fractions. When I'm multiplying fractions, tops get multiplied and bottoms get multiplied. We actually end up with 350 divided by 50, or 7 centimeters. Or just 150 for this. Looking at the 4.75 meters, turning into centimeters. Again, it's 1/50th of this, so we're really dividing with 50. We get 9.5 centimeters. So, we can also do it in meters. Notice that 3.5 meters over 1, we're going to change it using the ratio that we have. Well, actually, this is the calculation just to change the meters into centimeters over here, and same here. Going over here. So that's pretty obvious calculation. We just multiply by 100. Alright, so here are the final dimensions. 7 by 9.5 centimeters. So, if you need to, just scroll back in the video and listen to parts again that you might not have caught first time. And in class tomorrow, you'll be completing questions 1 to 10. And I'd just like you to start tonight after watching this video just doing question 1 before you come to class tomorrow. And we'll see you then.